It is not permissible to connect a 220-volt motor to a 480-volt variable speed drive, often abbreviated as VSD. This configuration will lead to an overvoltage condition on the motor, increasing the likelihood of motor failure and potentially causing a complete burnout. Connecting a motor to a voltage significantly higher than its rated voltage will cause the motor to draw excessive current, producing more heat and stressing the insulation. The relationship between voltage, current, and power in an electrical circuit dictates that if the voltage is significantly increased while the mechanical load remains the same, the current drawn by the motor will also increase to compensate. This can lead to overheating of the motor windings and premature failure of the insulation. Furthermore, the full load amps will be significantly higher than the motor's nameplate rating. Motors are designed to operate within a specific voltage range, and exceeding this range can cause the motor to draw more current than it is designed to handle. This increased current generates excessive heat within the motor windings, which can degrade the insulation and ultimately lead to motor failure. Variable speed drives are designed to control the speed of electric motors by varying the frequency and voltage supplied to the motor. However, they are not designed to be used as voltage transformers to significantly step down the voltage. When matching a motor to a VSD, it is crucial to ensure that the voltage ratings of the motor and the VSD are compatible. Using a VSD with an output voltage that is significantly higher than the motor's rated voltage will cause the motor to draw excessive current, overheat, and potentially fail. In the scenario of connecting a 220-volt motor to a 480-volt VSD, the motor would experience an overvoltage condition. The motor's insulation is designed to withstand a certain voltage level, and exceeding this level can cause insulation breakdown, leading to short circuits and motor failure. It's important to understand that a motor's full load amps rating is based on its design parameters, including voltage, horsepower, and efficiency. When a motor is subjected to overvoltage, its operating characteristics change and it will draw more current to compensate for the increased voltage. This increased current can cause the motor to overheat and fail prematurely. When selecting a motor and VSD combination, it is crucial to consider the voltage ratings of both components. The VSD output voltage should match the motor's rated voltage. If the voltage ratings are not compatible, the motor may be damaged or destroyed. It is also important to consider the motor's full load amps rating and ensure that the VSD is capable of providing the necessary current to the motor. Using a VSD that is not adequately sized for the motor can also lead to motor failure. In addition to voltage and current, other factors to consider when selecting a motor and VSD combination include the motor's horsepower, speed, and torque requirements. The VSD should be selected to meet the specific needs of the application. In some cases, it may be necessary to use a step-down transformer to reduce the voltage from the VSD to the motor. This is a common practice when using a 480-volt VSD with a 220-volt motor. However, it is important to ensure that the transformer is properly sized and installed to avoid any problems. Moreover, when dealing with electrical systems, always adhere to the National Electrical Code (NEC). The NEC provides guidelines for safe installation and operation of electrical equipment, including motors and VSD. Understanding and following the NEC is essential to preventing electrical hazards and ensuring the safety of personnel and equipment. One example is NEC Article 430, which covers motors, motor circuits, and controllers. Within Article 430, there are several sections that address motor protection, overcurrent protection, and conductor sizing. Consulting the NEC is always the first step when designing or modifying an electrical system. Wiring a 220-volt motor to a 480-volt VSD without proper voltage transformation or consideration of the motor's operating characteristics is a dangerous practice that can lead to motor failure, equipment damage, and even electrical hazards. Always ensure that the voltage ratings of the motor and VSD are compatible and that the VSD is properly sized for the motor. When in doubt, consult a qualified electrician or engineer. The overvoltage can damage the motor's insulation, causing it to break down. The motor's insulation is designed to withstand a certain voltage level, and exceeding this level can cause the insulation to degrade and fail. This can lead to short circuits and motor failure. Secondly, the increased current can cause the motor to overheat. Motors are designed to operate within a specific temperature range, and exceeding this range can damage the motor's windings and other components. This can lead to premature motor failure. In general, the full load amps of a motor are determined by its horsepower, voltage, and efficiency. The formula for calculating the full load amps of a motor is as follows: amps equals horsepower times 746 divided by volts times efficiency. When a motor is subjected to overvoltage, its operating characteristics change, and it will draw more current to compensate for the increased voltage. This increased current can cause the motor to overheat and fail prematurely. It is important to consider the full load amps rating of the motor when selecting a VSD. The VSD should be sized to provide the necessary current to the motor. If the VSD is not adequately sized, it can overheat and fail. Furthermore, using a 480-volt VSD with a 220-volt motor is not a safe or recommended practice. It can lead to motor failure, equipment damage, and electrical hazards. Always ensure that the voltage ratings of the motor and VSD are compatible and that the VSD is properly sized for the motor. Consider a scenario where a 220-volt motor is connected to a 480-volt VSD. The 480-volt supply to the motor is more than double the motor's rated voltage. The motor will immediately draw a large amount of current in an attempt to compensate for the increased voltage. This high current can quickly overheat the motor's windings, leading to insulation breakdown and ultimately motor failure. The increased heat generated by the excessive current can also damage other components within the motor, such as the bearings and rotor. In addition to the risk of motor failure, using a 480-volt VSD with a 220-volt motor can also create a safety hazard. The high voltage can pose a risk of electric shock to anyone who comes into contact with the motor or its wiring. In order to prevent motor failure and ensure safety, it is essential to use a motor and VSD with compatible voltage ratings. If a 220-volt motor must be used with a 480-volt power supply, a step-down transformer should be used to reduce the voltage to 220 volts. The transformer should be sized to handle the motor's full load amps. The transformer must be installed by a qualified electrician and properly grounded to prevent electric shock. In summary, connecting a 220-volt motor to a 480-volt VSD is not recommended. The overvoltage condition will damage the motor, increase the risk of electrical shock, and violate electrical safety codes. When selecting a motor and VSD combination, always ensure that the voltage ratings of both components are compatible. If they are not, use a step-down transformer to reduce the voltage to the motor's rated voltage. The transformer must be properly sized, installed, and grounded to prevent any problems. Always consult a qualified electrician or engineer when dealing with electrical systems.